Oh, okay. We're good to go. So hopefully you all are here for Estelle's webinar, Solving E-commerce Challenges with Visual AI. If this is not where you intended to end up on Zoom, that's okay too. You're more than welcome to stay and learn along with us today. So my name is Naomi Freeman. I am one of the leadership fellows for the track, and we also have Sapphire with us. So you'll see her in the chat as well. So when I'm responding to your chats, it'll be fellows at. When Sapphire is responding, she's Sapphire today in the chat. We also have a whole bunch of other track leads who are leading other areas. Today you're in one of the data science track webinars, but please go and check out the rest of Women Who Code's events and the other tracks. We have front end, mobile, cloud, blockchain, all sorts of things for you to check out. At Women Who Code, our mission is to inspire women to excel in technology careers. So we envision a world where women are representative as technical execs, founders, VCs, board members, software engineers, across the board in every area that you find other humans in technology. Women Who Code is currently comprised of about 230,000 members, 70 networks across 20 countries. We've seen a lot of participation globally today. I would like to let you know that I am calling in from Norway. My leadership fellow pair, Sapphire, is calling in from Northern Ireland. Estelle, I believe, is in the States.
Yes, Atlanta.
Atlanta. So our movement at Women Who Code, as the world changes, we can be a connecting force that creates a sense of belonging while the world is being asked to isolate. So please join in the chat. Make sure you put in your Q&A. We'll try and answer some questions at the end as well. Say hi to each other. Let's make a great community. We do have a code of conduct here at Women Who Code. We are an inclusive community. We would encourage you to read through the entirety of the code of conduct at womenwhocode.com/code-of-conduct. Our events are intended to inspire women and anyone who is also here for this purpose. You're all welcome. So be kind, read the code of conduct. Thank you. As I said, we have the other track communities. And we would love for you to join us in the data science track. We do have a Slack community that you can begin by joining. Sapphire can drop the link for that into the chat. There are other ways to get involved. We're always looking for volunteers, especially now that we're online. It's a great opportunity to be able to get involved. So feel free to email either of us, Naomi at womenwhocode.com, Sapphire at womenwhocode.com, to find out how you can get involved more. And we would just like to thank our amazing sponsors today, especially the Home Depot, for hosting and making these webinars possible. And you've already been chatting to Estelle a little bit. I'm going to tell you a little bit more about Estelle. She's a senior manager of the Home Depot data science team based in Atlanta. Before her career in e-commerce, she developed solutions leveraging machine learning for cancer detection, image segmentation in biomedical applications, and automated decision-making in finance. She holds a PhD in computer science for her research on image analysis and pattern recognition from the University of Paris, and pursued her postdoc in machine learning at Carnegie Mellon University. Just casual, she also holds 6 patents. 7 years ago, she joined the Home Depot, and in that time has made core contributions to e-commerce functionalities, including optimization of internal search, development of recommendation algorithms, and now growing the visual artificial intelligence capabilities to improve overall online customer experience. So you're going to hear about all of that in a few minutes. But first off, we're going to start with a couple of questions for Estelle about her extraordinary career so far. So I'm going to sort how I stop my screen sharing. And we're going to put Estelle front and center. And my first question for you today, just to kick off, can you tell us a little bit about yourself and your career path so far? I mean, I think a lot of folks are curious, how did you get to where you are today?
Well, first of all, thank you so much for organizing these wonderful opportunities. We are all, confined and trying to stay safe wherever we are, and really appreciate that you are really putting so much effort in connecting people and staying all together and growing the community. So thank you. Regarding the question about, how did I end up here at Home Depot? I've been here for 7 years now. Definitely not a straight path, definitely not something I could envision when I grew up, because that was not a discipline, data science didn't exist at that time. So not a straight path. There's been ups and downs, and there have been some turns. But really what has been always a motivation for me is my curiosity and the innovation. So curiosity and innovation is what has driven my path. And I would say the common thread through my journey is really the scientific approach. I'm just very grounded in scientific mindset and the logic and the reason of it, and also the interdisciplinary. I love to learn new fields, understanding what are the specifics of the vocabulary, the ontology, if you want, the problems, what metrics are needed, what are the goals to obtain, what are the constraints. So really, the path has not been straight. I actually started, studying biology. I wanted to understand how, from a single cell, we could, create such an organism with, all these multiple functions. And when I studied biology, I, discovered genetics, and I wanted to learn more about genetics. So I went through, biochemistry, understanding how these reactions, could come to this output. And from there, with a degree in biology, I'm like, I need to, extend that. I couldn't picture myself, working in a lab all my life. I needed to associate that with something else. Already you could see, the interdisciplinary here. I wanted to associate it either to business or to English. At that time, I was not fluent. I'm a little bit better now in English. But so either business, English, or computer science. Decided to go with computer science and got the virus of how we could automate and leverage, the computers to do some tasks that are very tedious for humans. And at that time, it was really counting cells. We were, growing some muscle stem cells, taken from biopsies of patients. I wanted to identify and optimize the media to grow these cells into functional muscles. So that was fantastic, learned a ton about image analysis, and that's how I grew into my my PhD on that topic. Based on that was great. We had these images, we could count the cells, we could put this information in database, but there was one thing that was missing is the interpretation was still done by the human individual, and an expert, obviously. So this is what motivated me to pursue toward machine learning, where we could actually teach the computer to draw these conclusions. And actually, the computer in some domains that it's even better than the experts. So that's where I went to Carnegie Mellon and continued in bioengineering, and that's where I learned all about machine learning. The focus was really how to detect, to predict, from images in which organelles the proteins were. So along the way, yes, there has been some discoveries about, how to use that techniques to identify biomarkers, early biomarkers of cancer. So as you can see, going from biology to, computer science and to machine learning. After that, my personal life, had 2 pregnancies. I'm happy to have, 2 children. At that time, I was more consulting at home, so to, manage and balance, the expectations of work and life. And then I was ready to go back to the market. At that time, definitely took a turn by joining Home Depot, and that was 7 years ago. So it's a retail. I still apply and use the techniques I have learned in the past to these new problems. I've definitely learned also new solutions, but definitely love and enjoy always being at the interface of disciplines and being able to use and understand what can be used, what we could use as solution to solve problems. That's a pretty long answer, but it gives an overview. So really, no straight path, not something that I could have predicted, even with the best model.
I think it's an amazing career path. I'm really, really impressed, and I'm so inspired by you as well. And yeah, that's incredible. So biology, computer science, machine learning, and now you're in the Home Depot, and yeah, I'm so inspired. So yeah, so can you tell us about what skills is a must know in your field, to let all of our attendees know what skills you need?
Yes. So actually, computer vision, it's not new, but there's definitely been a revolution, in 2012. So not new in the sense that, from very early on when the computer, started, being used, in the 60s of previous century, we were interested in, understanding what pixels, were representing, etc. So in the field of computer vision, this image segmentation, image classification, object detection, I think I will go a little bit in my presentation of those, so I will not spend too much time here. Definitely we need, the general and core machine learning techniques, regression, unsupervised learning, supervised learning. And then if we go more toward, videos, these, or the tracking domain. So these are just very generic, high-level keywords of fields that are used for computer vision.
Yeah, I think that's really helpful to understand. And we're going to get to your presentation just real quick, but in one small sentence, or maybe two small sentences, what do you think the most important thing has been for you in kind of ending up where you are? Or what advice would you have for others who it's not possible to set off in that similar direction, but how do you let yourself go to that opportunity and possibility?
You're absolutely right. I mean, I know people who are, goal driven, they set a goal and they go after it, and I admire them. And I wish, I had, either a vocation or a goal to pursue. It's actually not my, my philosophy or my approach. So what has helped me is really the flexibility, being able to just hear, the opportunities, that were around. Besides flexibility is adaptability, to be able to really quickly understand, how things work around, and kind of, keep your thoughts about, what you know and what you have learned, but also be open to what's new. So flexibility, adaptability, I would say also, dependability. So this is, it's not only for data scientists, it's for everyone. If you're dependable, you definitely will gain some traction. Besides that, I would say that, you need to trust your instinct, and you need to know what you need. What are your needs? And you need to define your own metric for success. How do you define success for yourself? Is it, what does fulfill you? Is it, achievement of, helping people? Is it, the interaction with people? Is it developing a solution and being able to have it, released and adopted by the audience? So defining your success will really help you shape, where's, the best move. Now, every move, is not always a success. There are some failures, some success, but every experience definitely builds up, and you gain actually experience and wisdom through this experience.
Thank you so much for sharing. I really appreciate it. I think that's all really valuable advice, and I'll let you take it from here to get into the presentation.
Sounds great. So thank you again. So there will be some time, hopefully, at the end for questions. So I'll go through this presentation, solving e-commerce challenges for visual AI. So in today's world, the customer's expectation of what the different industries should provide as a best experience has definitely, evolved and is higher and higher. So if you think about, banking, traveling, food, all of this, it has been really a revolution the past few years. We don't go to the bank anymore to cash a check, for example. We don't need to have actually a physical credit card to purchase things. So this is true also in e-retail, and this is the story I'm going to tell about, Home Depot. So quickly through this presentation, I will go through the introduction of Home Depot, but really focus on how we use, images and visual AI to extract knowledge about the products, about how to power some visual experience and drive visual recommendations. So Home Depot is a North American company. So we have some more than 2,000 stores spread across the US and Mexico and Canada. So we are pretty focused North America. It's driving more than $100 billion sales per year. So it's definitely a sizable. It's number one retail in what we call home improvement. We are driving both sales from stores and online. So as you can imagine, the inventories are not the same, but most of the sales that we do online are actually end up being picked up in the stores. So we have a large presence in different communities and neighborhoods, and that helps. That helps creating the connection with customers and fulfill all the needs. Now, in terms of our online presence, which is really desktop, tablets, mobile web, and apps, we have definitely been awarded and recognized by some institution in that area. So we are trying to do our best and always thinking ahead of what to meet the customer's needs. So here I want to quickly go through example of a customer that I called Alice, who's going to the store for a patio set and see that there are actually additional options available and color and materials from the online inventory. So goes back home, discuss with the husband, decide on the model, purchase the item, decide to benefit from the ship to store option. Then receive the confirmation that actually the order has been completed, with some additional recommendation about what could go well with it to complete the experience of enjoying the patio outdoors. And then once the order is actually available to pick up, most of, and as you can see, 60% of the orders online I pick up in store. Most of the customers are actually adding to their cart at that time to complete their journey. So what we mean by interconnected is really the combination of the physical interaction, either with the associates in the store or when somebody is coming into your house and to install the purchase, or through rental tools, with the virtual interface, which could be again through the screens, through the text, through the emails, or through the phone. So this Home Depot has really put an effort on having a very intertwined experience where customers is unique, but as you can see, there is a complexity in the sense of there's multiple touch points here. And you can already imagine the data science challenge just for that reason. But really, we want to build, just one journey for the customer, and not put them on the spot of saying, hey, no, this is not us. This is another team. This is not. We are not responsible of it. So that definitely requires some efforts. So from Home Depot, here, just want to put this home improvement, sector and business in perspective with other type of retail. From this diagram, I really want to put it under two directions where these either you're familiar or unfamiliar with a product, and where it's easy or not to take the decision about the purchase. So if you think about, office supplies, like, paper is kind of an easy product, and it's easy to reorder once you are out of it. Similarly to, computers or grocery, you're kind of familiar with products, easy decision, you click, you get it. Where it's a little bit more complex and needs some more reflection is about, clothing or travel. In that case, you might be familiar, but it requires some, thinking to actually, match the needs. Where, home improvement sits is really in that quadrant where products are actually, there's a large variety of those, not necessarily familiar in terms of, names or in terms of usage. So you need some expertise. And yes, it's just harder to take a decision. You don't choose, a paint for your walls the same way that, you choose, a pair of shoes that, you could change from day to day. So this is where we are. And really, Home Depot encompasses, all these different departments, going from the hardware, lumber, electrical, plumbing, everything to build a house. But also has grown and is growing more and more towards the, finishing or the decoration of the house with, furniture, rugs, everything for the bathroom, kitchen, and bedroom, going from floor to ceiling and from paint to lighting. So these categories are really the core of Home Depot. So, so how do we help customers? So here I'm going to take an example which is outside of Home Depot's spectrum, but I thought it was a little bit easier to explain how voice and visual search are actually growing in e-commerce to help customers. So actually voice is already representing for Google search more than 50% of the search as of 2020. So we know voice is definitely a growing trend. Visual search is as well, not necessarily for the same kind of questions. But here, this is an interesting analysis or study that has been done by Bloomreach, where they asked 500 customers to describe, it was not exactly that dress, but a dress which is similar to that one. And from these 500 descriptors and descriptions, and we see here, six different aspects of the dress, which is, color, fit of the dress, the occasions, the neckline, the length of the dress, and the material. They're actually, just to describe the color, there's been 129 different terms that have been used. To describe the neckline, 194 different terms. So this is really where we can sense the complexity of describing something that's unique. Everybody was talking about the same dress, but having some personal or some subjective terms to actually describe it. And that goes back to everybody's background is different, everybody's vocabulary or sense is different. So so in that case, it makes sense to actually use the image to unify all these descriptors. So this is true also, obviously, in home improvement, where we can describe a chair or a rug with a lot of words without necessarily being able to describe it, in its entirety. So how do we tackle that in Home Depot? We have actually started the data science team. When I joined Home Depot, actually, the data science team didn't exist. So when I was talking about being flexible and open, I actually joined as a product manager at Home Depot with a mission and role to improve the search engine. But at that time, data science didn't exist. So when data science, really kick off and become an entity in itself was 5 years ago, and we were only 3. We are definitely grown into these now different areas that we have structured the team around. So we are really focused around recommendation, search, visual, and growth. So in the growth, we definitely have this voice as part of it, and really foundationally the platform, which really enables our data scientists to not only deploy, which is very important for us, not just build the models, but also use them, but also raise the, I would say, the productivity of our data scientists by not repeating some tasks such as preparing the data, normalizing the data, cleaning up the data. This should be, when possible, when we are growing, this should be centralized and usable by all the different projects. So super important to actually build the infrastructure and the platform to support all of the different developments. So focusing on what I'm currently leading, which is a visual team, these are different activities and actual life cycle that we are doing. So it goes from the exploration and learn activities, by doing some research and generating some insight and recommend some strategies. So really the output of that activities are to drive insight and decision. For example, what's the best opportunities, or what's the size of opportunity to update or upgrade or build a new experience. Another component is to develop solutions. So here we absolutely need to understand, what's critical to business, to understand what's the objective, what are the metrics, and sometimes defining the metrics when they don't exist, to be able to, again, build a model and evaluate it. So evaluation happens in two folds. We evaluate it, offline based on the data we already have, and then we also like to test, through A/B testing. And last but not least, because that's actually the ultimate goal, is to really use these models to improve the experience in production. So here, the journey is not over for the data scientists. We want them to partner with engineers to not only deploy, but also optimize and thinking about the next version. So I think I mentioned, really quickly during the question at the beginning, what are the different activities that and techniques we are using in computer vision and machine learning. So this is just a quick summary. All right, so moving on to the first area that I want to introduce today is how we actually leverage the images to extract knowledge about the product. So first off is, what's the best image? Actually, so we have millions of products in our catalog. For each product, we have multiple images. And we know for each image, which product they are associated with. But the things we don't know is actually what view of the product we have. So we have actually, the fact that this is a lifestyle for two different products, and that's a product image, and that's a detail or just part of the product, or the back view, or the open view. This is actually not labels that we do know. So we have, that was one of our goals to predict this, and the reason we want that is for two reasons. One, very selfishly, it will be the input of all the algorithm we are going to use. That means when I want to create an experience, which image should I use? So what is the best image is obviously dependent on the application. The best image to inspire a customer might be the lifestyle. The best image to show what's the texture of the table is probably a detail. So we actually need to learn and to predict what's going to be the label of this image to be able to serve the customer wherever they need to be, wherever their needs are. So to do that, I'm going to actually take this segue to introduce how we use classification of images and really compare the before and after 2012, where before, and that's what I grew up with, is a traditional machine learning flow. So here I present a classification. So in the middle, you think about a classifier where we have as an input an image, and as output, we are going to predict the label. It's a supervised approach, so we definitely need to have a label set at the beginning, which I didn't present on that slide. We have a label set, and we're going to split that set into the training and testing. Training is going to be used to modify the parameters of the classifiers to optimize the prediction. So here I really represent, example of classifiers that have already been trained, but just wanted to introduce a difference between, if you're not familiar with computer vision, the difference and the breakthrough of deep learning into our world. The previous and the traditional approach of machine learning to do this type of classification tasks was to first extract the features. So this is, feature engineering. So we were going to collect, features that we, as a human, as a data scientist, were deciding. We're going to say, hey, we're going to extract the color histogram. We are going to extract the orientation of the edge or the texture. So there are, multiple, now available libraries, but at that time, very cumbersome ways to implement all this feature extraction before feeding these features to a classifier so that it could predict the label. What's really has changed with deep learning is actually both the task of feature extraction and classification is happening into one system, one model, where the different layers are being updated, the weights on the different layers are being updated based on, again, the training sets. So this, how deep learning has really helped with two things. First, with deep learning, we can continue to grow the performance with the number of images that we keep feeding. So you probably have heard, how to the task of recognizing a cat from a dog. So this was, hitting some plateau. We were, hitting some ceiling when we were using the traditional approach. But with the deep learning and the fact that we could feed a lot of images, so it needs a lot of images because there's a lot more parameters in this approach than in the traditional one. But really, we could increase the performance. By performance here is obviously the accuracy of the prediction. So number of images being available is key to the success of using deep learning. It's using a lot more resource, so it's slower to train than the traditional approach. Nevertheless, it's not slow once trained. It's actually very fast to use. But definitely, having access to more resources such as the GPU or TPU has been needed to use this deep learning approach. So again, fantastic breakthrough, and now it's becoming the common approach, but not disregarding this previous 60 years of that traditional approach. So we are using deep learning approach. We are actually comparing both to predict the labels of our images. Another example of and that actually is using more of the traditional approach of using the images to extract some knowledge is how to predict the style and the room of the product using this three sources of information: the image, but also the features of the product, as well as the description and reviews, so more of free text. So here we took the traditional, and that's because it's techniques that we used and implemented a little bit earlier in the maturity of our team. But we were and we are extracting features. The type of source of signals here are different, so we're using different methods to both extract the features and use classifiers. So again, each time here we are using multiple classifiers and we are comparing their performance. We are combining the output of these classifiers to actually, increase and boost the accuracy. So here, if we take this example of, after training these classifiers, the output that we can expect is the style and the reliability of and the likelihood that this style is going to be, as well as a room. So if you see that, the sum is more than 100% is because the way we architect this is definitely based on the business needs. And the business needs was at that time, we don't, if a product has more than one style, we want to know that style. We don't want to say that it's more glam if it's less classic. No, we might be very confident that it's a glam product, and we might be also very confident that it's classic. So we did build actually, binary classifiers where each classifier was deciding, is it glam? Yes, no. Is it classic? Yes, no. Is it coastal? Yes, no. Is it rustic? Yes, no. And based on the threshold, based on the likelihood and threshold that we set, we could determine, yes, this product is actually, of that style. So this is just two examples, from where we can help from images extract additional information. Now, regarding the experience, following up on labeling the images and knowing what type of views they show, we can obviously use it to now drive a smoother, more homogeneous view of our products. So when we look for chairs and we have this diversity of return product, in the original version, we had, the first product was showing a lifestyle, second was showing, a set of chairs, third was showing the front view of a single product. So by using, the labels, we could now, homogenize and harmonize the view. The techniques we have used and we have seen then is image classification, and here segmentation when we want to actually show only one product when there are multiple that's composing the image. Another one is borderline AI, but I like to use AI and artificial intelligence in this broader definition, where everything that can be automated is actually helpful. So here, what I call augmented image asset is starting with existing images that we have in our catalog. How can we enhance the experience of customers? So one example is what we call bundle. So the bundle of appliances is when we have a collection of appliances, refrigerator, dishwasher, microwave, and ovens that go well together, either because it's generated by the vendor this way, or because the algorithm has identified that the finish and the style is similar. Once we have identified that these products go well together, we want to create the experience where it's actually easy for the customer to identify this family of products. So here, it's as simple as it looks. Identifying the front view of each of these products, segmenting it, that means knowing where are the pixels that belongs to that product versus the background, and being able to compose based on a template this image, so we can power this experience. Another example of augmented image assets, starting with the image that we have. In the information we have about the product, we wanted to help customers to really figure out if the product that they were looking at would fit their needs or would fit the space that they were trying to fill. So here we're not trying to extract the dimensions from the image. Actually, these dimensions are known and they are provided. But what we wanted is to help the customer to quickly visualize and not trying to figure out what's, amongst this, height, width, and depth, which dimension shows where. So leveraging its various classical image processing and image analysis techniques here, figuring out what's the main component of the image, defining the height and the width, and displaying these two bars to start with, refining with the different orientation of the silhouette of the object. So we could set the bars, display the bars at the right place and at the right length for, again, easy interpretation for the customer. Another more advanced approach to power experience with images has been nice project about the app. We have a specific app to choose a color of paint for your walls. And so it's called the Project Color app. And here the first challenge was, among the more than, several thousand colors that we have in our palette, and obviously the inventory of these colors are not always the same. So we needed a dynamic way to sort these colors into an appealing experience for a customer to choose quickly or to browse quickly and choose within all this nuance. So here we explored what I call the color science. We are probably familiar with the way to represent a color through the RGB, so the 3 dimensions, the red, green, and blue components of a color. It happens that when we calculate the distance between two RGB coordinates in the Euclidean space, the human perception doesn't have the same notion as the Euclidean. It's not proportional to the Euclidean distance. And as an example, if we are looking at a light yellow with a dark yellow, and it seems that for us it's as far away or as distant as a light blue and a dark blue, it's actually not at all the same value in terms of the Euclidean distance. So there's been different 3D space that have been developed for that exact purpose. One of them is the LAB space, where actually one dimension is just representing the luminance, and the 2 other dimensions, which are generic letters A and B, are represent just on these 2 dimensions will represent the color. So that will help a lot. And in that space, it has been specifically designed so that the perceived distance is actually very much similar into the Euclidean distance value. Still, we were challenged with how to represent a 3D to a 2D. So there have been multiple iterations, but that's part of the experience and learning how to make the product better. So this is currently helping our customers. One other feature that's helping our customers, which is currently online as a beta version on the app, is how to help the customer visualize how this new color would look on their wall. So they are taking a picture of their own room, selecting the color, and we are showing how it would look like. So we have a beta version, and we are currently working on an improved version of it using different techniques, including image segmentation, image edge detection, so really to limit and control where the spread of the color should start and stop. Color similarity to distinguish between the different elements, and also the rendering with the color and luminosity rendering. So this is already an advanced and complex project, but this is where the fun is. So these are a couple of examples to drive how we drive the experience. Now I would like to switch to how we use images to drive recommendation. So recommendation, you're probably familiar with how we use the crowd behavior based recommendation. We use the behavior of customers to drive customer who viewed this has bought that, or customer who viewed that have also viewed other products. This doesn't leverage the images. We moved, in terms of again maturity to drive the comparison of products, not only integrate, the crowd-based behavior when available, when we saw that customers were comparing, but also the product attributes. So here the benefit is if the customer behavior is not available, we can still generate the similarity between products based on their characteristics, the height, the length, the finish, the different options, the cubicle fit if it's a refrigerator, etc. So the advantage here is it's not sensitive to the course start, and we could cover a lot more of this recommendation. Now we enter our world, my world, where we actually want to also take into account the aesthetic of the product to drive the recommendation. So as a quick example, here what we drive is more like this. So if you're looking at that mirror, we want to show you, alternative, and you decide if actually the alternatives are interesting for you or not. But we want to show things that are relevant. That means sharing some characteristic, aesthetical characteristic from the initial product. So how do we drive that? Very similarly to what we have shown earlier. We're going to use, here convolutional neural network with these different layers, where each layer is capturing one element of the image. They are, these elements could be, the fact that there are some textures, that there are some lines, that there are some round objects. So all of this is automatically trained and learned through these layers, which replace, all the feature extraction we were doing manually before. And here what we represent is represented in purple is really the classifier. So we can use a pre-trained classifier. They are available, publicly available, open source pre-trained classifiers that have been trained on recognizing thousands of different objects, indoor, outdoor, from people, cars, sky, beach, kites, everything you can name. These classifiers are ready, and what their output is going to be is, hey, is this a car? Is this a bike? Is this a table? But what you can do is adapt these last layers, which are really the classifier, into your own purpose. So this is called transfer learning. If you want to use the mechanism that has, the features that have been trained to recognize this 1,000 object, but actually you are interested just in cats and dogs, you can just change these layers. When you train your classifier, you freeze all these layers that you're going to reuse, and you're going to train just to recognize at the end, just you want, 2D, which is cat and dogs. So, so this is, the traditional way to use a classifier. Now, how do we use it for visually similar? Is if you use actually the last layers, that means the embedding, which is a representation of the features of the image, not necessarily something that the human could interpret, but actually this embedding, which is, you can imagine a long vectors that can be, more than 1,000 dimension long. It's really, the way to represent it is in a space of, the same size. That means if you have a vector of 1,000 as a dimension, you have a space of 1,000 dimensions, and each of this image is going to represent one location based on this 1,000 coordinates. So the space, here is a representation in 2D. The space is going to, the way the space works is images that are similar are going to be in the same area, in the same region of this 1,000 dimension space. So here you can see that, all the furnace are going to be in that place, all the pots are going to be here, and the lanterns are going to be there, and the plants here. So how can we leverage that to actually drive recommendation? Is we're going to calculate the distance. We're going to use a cosine similarity to calculate the distance between the different products to measure how visually they are, how similarly visually they are. Another thing that we want to drive is now the coordinated items. So showing here, bathroom setup where, we have a nice composition of the faucets, the lights, the floors, the bars that go well together and create an harmonious composition. How can we drive the recommendation for our products? Well, we can leverage lifestyle images that have been composed by interior designers, and from there extract, identify what type of objects are there. You know, the chair, pillows maybe, and lamps. And from there, so that's the object detection. From there, being able to identify in our catalog what is similar. What is similar is in color, shape, style. But you know, by giving this and finding these products, we could create some composition of rooms that actually are harmonious. So this is going to conclude the presentation for the recommendation. Just one note on what's next. We are far from, you know, having extracted everything we could from the images. We have started with the most obvious and the most beneficial for customers, but there's a lot more. In terms of visual experience, we can, you know, continue to grow in terms of how to help customers to visualize how the future product, you know, would fit and would look in their environment. Visual recommendation also has a lot of potential, particularly toward, you know, personalization. So knowing the tastes and preference of the customer, how do we help them navigate through the catalog? Visual search, that was one of the areas that's, you know, growing. Both visual and voice search are going to be, you know, dominant things, you know, in the future. With the help of AR and VR to again visualize where and how the product would look, and I would finish on that note about, you know, thinking out of the box, and this is from Stitch Fix, where we can create product by a combination of, you know, the preferred features of other products. So if we want something, you know, which is sleeveless, which has a floral pattern, which has a little bit of, you know, ornaments on the side, you know, we could combine these elements to create actually a new product. So this is the end, but hopefully we can, I can answer some questions.
Thank you so much, Estelle. That was a fantastic webinar, and it was so good to hear about the amazing things that you and the Home Depot are doing. We actually have a good few questions here. So the first one is from Wanda, and I hope I pronounced your name right. She's asked, are there any special considerations involved in bringing machine learning models into production?
Consideration, yes, of course. So, you know, we have always, you know, started small and going bigger. We have always started with a solution that's the simplest and then, you know, build upon it. So when we build things in production, we always need to think about, you know, the maintenance. So for us, you know, the way we started is really, hey, we are going to deploy only, you know, the train model. You know, the training is going to be part of, you know, what we do in our lab. Once it's trained and we can, you know, scale it up to the size of the catalog, then we can, you know, push it in production. So we're not, I mean, the ultimate situation would be where actually the training, and that's part of, you know, reinforcement learning, where the training and the learning is actually continuous, and you know, the model actually evolves with, you know, more and more feedback. What do we need to consider when we want a model to be put in production? Well, to understand what the production can support, and how if they don't support a type of formats, you know, TensorFlow or PyTorch, for example, we need to understand what's the level of effort to actually make it happen. So based on the answers, the level of effort, we need to actually, as data scientists, choose different model, because, you know, the level of effort is too much for deploying that model in that format. So always it's a continuous discussion between what's possible in terms of deployment and what's possible, in terms of best model. One example is actually that I presented here. See it in your space for the painting. Here we want a real-time response on mobile. So we want to make sure that the model we choose are compatible with deployment on the mobile device, both Android and Apple. So that means that might not be the best possible model that exists, but that's within these constraints, that's going to be the one that offers the best solution.
Thank you, Estelle. And another question here is, does Estelle's team have contacts and information flow with particular business units at Home Depot?
Sorry, could you repeat this one?
Yeah. Does Estelle's team have contacts and information flow with particular business units at the Home Depot?
With contacts and business, yes, we have a lot. I mean, if it's about partnership and business interaction, we are not isolated. We do work with multiple teams. We do work with the paint, with Windows, but we work also with marketing. We work with our main partner is a product management of the website, which really helps delivering the experience and vision to the finish line. That means they are the one coordinating with UX, with engineering partners, how to actually deliver not just the data science model, but the full experience to the customer. But we have a lot of contact if that's a question. Yes, we are not isolated.
Thank you. And another one here from Michelle. Hi, how many images did you require to get a decent performance?
Yeah, so that really depends on the task, and the sense that if we are looking to distinguish, a cat from a dog, where there are a lot of similarities, you will need a lot more images than to distinguish, a chair from a dog, where it's just a lot more obvious, and the few rounds of iteration will have, so it will be enough. So so here, we won't do anything, less than 50, 100 images, when things are obvious, to more than a few hundreds when it's more difficult. So it's still required, some labelings, and definitely, something I'm not emphasizing that presentation, but human in the loop is definitely present, and we do need a lot of label data. Nice. Are we frozen? Hello.
I think Sapphire might be frozen. So that's really helpful. Let me see if I can just pick up where the questions were at. I suppose one of them is kind of around the structure of what you work on. So there's one question that's sort of, how do you structure your data science team? And another that's, which part of the process takes the most amount of time? They're wondering if it could be, for example, data exploration.
Excellent question. So I think this is, each manager of the team would determine what works best. I like to empower my data scientists to own a project from A to Z, from data exploration, understanding the business problem, to the release and testing, and understanding how it impacts customers. So again, that I think is dependent on the manager. But personally, yes, I like product to be owned by a data scientist, so he understands the ins and outs. What takes the most time? I would say the most time is really between preparing the data, collecting the data when not available, between this and the validation. By validation, I mean, the multiple iteration when, we first, assess the accuracy or whatever metrics we decide to pursue. Once we first have the first results, obviously it's not going to be perfect, and we need to revise our copy based on the feedback. And this, can take, a couple of rounds. It could take, longer rounds when it's more complex. So between these two things, this is what takes the most time. Building the model and adjusting it, tweaking it, retraining it, it is not as big. The support to production deployment is, is an on and off job. So at that time, we need to follow, the business space. That's why I love for my data scientists to have multiple projects in parallel, because there are some times where we have some dependencies and need to wait on those.
Yeah, that's really interesting. The final one that we can kind of cover, because we're going to wrap up in a couple minutes, and I just think this is a really cool question, is what was one of the most interesting or shocking things you learned throughout this process?
That, I don't know if it's shocking, but the human component is as important, if not more important, than the technical aspects. In the sense that you work with a team, but also you work in an organization. To be able to start a project and get it, all the way to for the vision to become a reality, you need a lot of partners, a lot of coordination, a lot of buy-in, and the human aspect is not to be underestimated.
I appreciate that point of view. Thank you.
Thank you, Estelle. That's all the questions then answered now. So I will share my screen and wrap up today. Yeah, there.
It was a real pleasure to be able to share our experience.
Thank you so much, Estelle. We're so pleased to have you here today. It's been absolutely incredible listening to everything you do at the Home Depot and your career experience as well. I'm just asking, can you all see my screen okay?
We do.
We can see it.
Perfect. Perfect. Okay, yeah, so this is us wrapping up now. So I'm just going to go through some events that we have coming up. So we have a panel series coming up next week, which is about being a woman in data science. And we have three fantastic panelists joining us, Andrea, Rhea, and Winnie. And that is next Friday. And also, we started a machine learning for social good workshop series yesterday by Keisha, and the recording for the first workshop will be available on YouTube soon. And workshop number 2 is coming up on July the 8th. And then workshop 3 is July the 15th. And we have, after the workshop series, there's an opportunity to participate in a mission predictable virtual machine learning hackathon, which will be on the 19th of August. And you can register for interest. This will be opening up very soon for registration, and you can also join a channel in our data science Slack group to get all the latest information. And Keisha is also in there as well if you have any questions for her. And we also have another workshop series coming up called Introduction to NLP, and this is a 6-week series. That will be starting on July the 11th. So if you want to register for any of these events, go to WWCode.com/data science/events. And this is our social media account. So if you'd like to give us a follow here on Twitter, we also have a Facebook page and an Instagram page. And our email is at datascience@WWCode.com. And you can also reach out to Naomi and I as well. Our email address, like Naomi mentioned at the beginning, is naomi@womanwhocode.com and sapphire@womanwhocode.com. And that is us. So a big thank you to everyone who attended today, and a huge thank you to Estelle and the Home Depot. I hope everyone has a great day.
Thank you. It was an honor. Take care, everyone.
Thank you.
Bye.
Bye, everyone.